back again? It's back again. So let's talk about generated. Let's say you don't know, you have a class, you don't know what module it comes from. What I usually do is I Google for Java, then the version, let's say Java 9. I know you can read the terminal, just trust me. Sorry, the URL line. I just searched for Java 9 generated because that was the class name, and then Java 9 to make sure I find the Java 9 Javadoc. And if we have it, it contains the information up here. So the package information was always there. Now it also mentions which module it belongs to, right? So every class mentions which module it belongs to. And then also, if you click on it, you will get more information about it. The small dependency graph, this one is really simple. It's deprecated for removal in Java 9, right? If you're already on this page, one of the biggest improvements in Java 9, there's a search bar up here. Woo! Look at that. Amazing. You can now search Javadoc from within Javadoc. Okay, so we found out that apparently generated is in this module. So, okay. Containing module Java. Then let's go to the POM and not that one though. Let's close utils. And we need to add that one as well. You can actually put that here, but I prefer to have each on their single line, just so, you know, when you delete one of them, you have a cleaner diff. But either way is fine. So now let's build this. Huh? Why does this happen again? That's bad classifier. Statistics snapshot jar. Can't make statistics. I have no idea why I have to build up on this. Like this, it's the wrong bytecode version. This is 9 and this is 11. Oh, that's IntelliJ. Maybe I switched to 11 somewhere in IntelliJ and it rebuilt something. But never mind, we can just go and build the big project. And now comes the trouble. Monitor server cannot find symbol non-null. The other two errors, we had them from the beginning. We fixed both of them and now a new error appeared. Compilation failure. Class non-null, can't find non-null. You're like, okay. It's also Java's annotation package, by the way. Can't find non-null. I think I primed you enough that you know where this is going. But let's have a look. Which class is it again? Monitor server. Okay, monitor server. Here's non-null. Okay, we know about this, right? The Java XML bind package, we fixed that. IntelliJ just doesn't know about it. What about non-null? IntelliJ doesn't highlight it. Indeed, if you control click it, it will go to the dependency. We can now go with the select in. We can go to the project view and then we'll select it here. Look, it's a dependency. It's a Maven dependency. Remember that? Why wouldn't it find that? There's a cool thing we can do. Let's hope it works. I'm not sure whether my IntelliJ theory earlier is the reason here. Let's add -x to Maven. Then you get a lot of detail. Shit, and this is not the error message that I was looking for. This is really annoying me and I have no idea where it comes from. But let's see whether we can still see. Yes, we can still see the part that I cared about. Because if you go with Maven compile or whatever Maven command you do with -x, you get a lot of debugging output. And this output is interesting here. Let's have a look. This is the compiler plugin. It tells you I'm using the compiler Java C. I'm adding this as a sources root to compile and new sources roots here. And then blah, 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 a couple of things. It needs to changes detect, it needs to recompile, and then it lists the class path. That's helpful. It lists all the stuff it's going to put in the class path. And have a look. It's there. And even if you look at the full command line options, you can still spot it. It's here. So what's going on? Why does it not find the class non-null, even though non-null is clearly in a jar that is clearly on the module, on the class path? What's going on here? we don't build modules, right? We on our own don't build any modules. So it's not because it doesn't reference it. Yay! That's not easy that's not easy to say. But yes, split module, exactly. So that's exactly the thing. This is this package is the Javax annotation package. And if we go back to monitor server, we'll see it's here, Javax annotation package. But if we then go to statistics entity, we'll see the same package here. Generated comes from this module. Contained. That's proper English. Talk about proper English. Pronounced was the word I was looking for here. But this is not in the module. This is in the class path jar GSR 305. And that sucks. Because now we have to do that, taking that stuff out, taking it out of here and stuffing it, patching it into that other module. That's very unfortunate. So the fix here is, I'm not going to type this out because it takes too long, it's too error prone. I'm instead going to look for, actually I can, well, let's patch module. We're going to take Javax XML WS annotation and we're going to put in the content of the JSR 305 jar, or 302 I think it is. How do we get there? How do we get the jar? I don't know, you could probably put into a lib folder or something. That would work. But you know, did you know that you can use this to reference Maven's local repository? And if you're in the local repository, well, you do know the artifact ID and everything else. I mean, you can manually go there. Wrap tag configure soft wraps. No, just active editor soft wrap. There it is. Oh, on. Yes, okay. Here it is. So that's not nice, but it works. That also means if you update the dependency, then you have to update the number. It's ugly. It's really ugly. But what that does is it takes the content of this jar and stuffs it into that module. And we're really lucky that JSR 305 has no additional dependencies. And because of that, it works now. Almost. Patching the system module is not allowed in combination with release. Oh my god, I advertised that so well earlier, right? Remember I said, like, we can use release here. Release is amazing because it does 3 things at once, and so we don't, like, okay, but it doesn't work with what we're doing here, unfortunately. So we have to go back to source and target. And I didn't know why that was the case until someone from the JDK team explained it to me, and then I forgot it again, or half forgot it again. So it just never mind. At this point, I basically gave up and was like, okay, let's just do this, because this happened to me in real life. Damn it! What? Oh no, source target? Huh? What's going on? Something is weird. I think it's related to the problem that I had earlier. Do I have to install maybe once at least? I don't know. Damn it. But there's no release in use. Or did I just update in the wrong place again? I think I did. No, it's up here in parent. Oh, I copy pasted this around, right? I told you copy pasting make... Yeah, see? As I said, copy pasting leads to errors. So I copy pasted that release part as that release version in the wrong place. Okay, good. We launched this. Sorry, we built this. Okay, let's now launch this. Now we can use the new option. Class path. Just because, like, we don't have to, of course, but I think it's just more readable. Wow, that didn't go very far. Java-line class cast exception. Java-based blah 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 cannot be cast to URL class loader. Well, I'm not even going to leave you guessing because this is very clear, right? Apparently we cast to URL class loader. Remember that when the project would run, I would in the beginning have a long list of jars there. The reason for that is because it wants to list the dependencies. Maybe somebody in ops had that requirement so that you can always look at the log and see all the dependencies that are there. And the way we did this is this. It's basically, well, we got to get the class loader of the main class, and we know it's a URL class loader, so we can cast a URL class loader because then we can access the getURLs method. If we don't do that, right, then there is no getURLs method. We're lucky. In this case, the problem that we're trying to solve has another solution that works just as well, because you have the system property, singular, java dot class path. That one that you get here, that contains the content of the class path as well. So as long as we just want to read the class path, we can avoid this cast locally by just doing something slightly different. I'm just going to do a Linux thing and split on the colon. On Windows, you have to split on the semicolon. So you would have to use the proper thingy on both operating systems, but I'm just going to ignore that for now. These are the class path entries. And now we're going to say stream.of class path entries. We're going to stream the individual entries, and I think we can replace this part. Oh, not quite. And we still have to assign the result to a message. So this, we're lucky here because we're just reading the class path, and that's easy. But if you want to change the class path, because you can do that, you can cast a URL class loader, and then you can change the class path by adding things while the program is running. Like if you have some plugin architecture, you can use that. If you use it that way, then this will not work on Java 9. It's not a matter of just finding the right API. On Java 9, the class path is, God damn it. On Java 9, the class path is immutable once the program launched. So you cannot later add stuff to the class path. It won't work, okay? That's very important. So you have to find another way to do that. And the other way is to create a new class loader that references the one that you already have and add new stuff there. Now, finally, can I has program now, please? I think I can. Almost. No class dev found error, Java XML bindjux B exception. Oh yeah, remember that earlier we had to add a module? Well, as I mentioned, most of the times you have to add, you have to have stuff, you have to do add command line options that you need for compilation. You also have to add that again for execution. And we're lucky here that we don't need to add the other module and that we don't need to add the patch. Usually you would have to, but because they're only concerned with annotations, and those annotations are only valid during compilation, so that they're not in the bytecode, they're not retained for execution. That's why we don't need that here. Okay, so we're happy doing like this. And hey, it worked. Java 9. There you go. So that was some of the problems you may encounter. All of the big ones were in there. But as I mentioned, I had to do quite a lot of work to shoehorn them all into the same project. You have a good chance of getting away with it. But with fewer of them, particularly if you update your dependencies first. So yeah, woo! Oh, happy day. Nice. That was Java 9. Can we move to Java 10 now? Let's move to Java 10 now. Let's update to Java 10 on the command line. Quickly check whether that worked. Maven -version. Yes, Java version 10. Okay, nice. Now we're just gonna keep, IntelliJ can keep complaining. That's okay with me. We're gonna go here and add another profile. So that's a bit annoying because then we have to copy paste this. You cannot like profiles, they cannot be inherited or anything. Like profiles are kind of not very, what should I say, like advanced or something, I don't know. I wonder whether you leave them like this when you add this to 10, what would happen now, but I'm not willing to find that out. Which, you know, whether both of them would be active and which one would override the other one, but I don't want to go there. So instead I'm just going to say this is just active on Java 9, sorry, and the other one is just active on Java 10. So keep in mind that means that our build works on Java 9 and 10, and even though that makes no sense, because if you run on 9, then you want to upgrade to 10, most likely you want to leave 9 behind. This would be a way to maybe make your build work on Java 8 and 11 and 14. Okay, so you can keep basically several versions apart. Okay, so now let's build with Java 10. Let's see. Would you look at that? It just worked. Let me prove you that I actually use Java 10. Let me tell IntelliJ about it first, so it doesn't complain even more than it already does. By the way, you can also just activate the different Maven profiles, but not in presentation mode because I don't know how to open the Maven tab. So you wouldn't have to go into the configuration manually there. So let's have a look. Object mapper is new object mapper. Well, isn't that obvious? Let's use var. Come on, what? Oh, I just did that. Okay, now it's done. Works. Neat. I want to show you something that can occasionally happen. Because what we're doing here is several tools that we're using and that we're relying on, they might do something with bytecode by parsing or manipulating it. And most of these tools use ASM under the cover. And what that means, what can happen is that let's say you're on a specific version of a dependency and then, of a build plugin of Maven, and then it uses a specific version of ASM. And then that version of ASM does not work on the newest Java version, right? Because ASM is built for specific Java versions. If it's built for Java 11, it cannot handle Java 12 features. It just can't. So that makes a lot of sense. So you might be occasionally be in a situation where you want to update that. And I quickly want to show you how that works, in case you don't know. So I just copy pasted this from off screen. So once I've fixed all the errors here, link to a Stack Overflow question, not that important. The important part is, once again, within the profile, I configure another plugin, and what you can always do, within each plugin, you can add a dependency block, and then you can update the dependency version there. So this way, I would use a newer version of the dependency than the Maven compiler plugin. I use compiler plugin in version 3.7.0. This would make me use a newer version of ASM. So if you ever get weird bytecode related problems, adding ASM would work, I guess. That said, another thing to do is to just make sure that you're running on the most recent versions. In this case, by the way, that's 3.8, or even 3.8.1. So let's use 3.8.1, and then we don't need to do stuff like this at the moment. But keep that in mind, you can always update a dependency of a plugin in Maven this way. But it already worked, or did it? Let's see. Well, let's first ask, what Java version are we on again? We're on 10. Okay, that's good. Then let's run. That looks good. Let's have a look here. That looks good. Everything hunky-dory. That was the Java 10 update. And that's normal. 8 to 9 might be a lot of work. Everything might be. Everything else will most likely not be a lot of work. Okay, that's important to keep in mind. Because like some people were afraid that, oh my god, the update to 9 was so hard, we're going to do that every 6 months now. But no, that's not the case. I mean, and that would also not be possible really. Doing that amount of upgrade work would just break the ecosystem's neck. I think the underlying idea was that the module system breaks the stuff with internals. Like if we look at the specific problems that we had here, most of them are not incompatibilities in the specific sense of the word, because they did not break with legal things that were legal in the past. The cast to URL class loader, that just worked, but it was never in the standard. JSR 3 or 5 should not be in that package. Java E dependencies, they are not part of Java SE strictly speaking, so we shouldn't be or rely on them being there. Using sun, misc, and save, rummaging around within the JDK folders, we didn't see that here, but those kind of things, we're not supposed to do those in the first place. And so these changes are not strictly speaking incompatible changes, but they were made as a consequence of the module system, and I think that they dumped a few other small changes in there, like changing the version string to basically have one big breaking update, in square quotes. That was Java 9, but 10 and 11 were much smoother then. Okay, so let's go to 11 now. And yes, I think the joke's funny too. Let's go to Java 11. SDK 11 mvn clean install. Actually, let's go back to verify. Okay. Compilation failure. Compilation failure, error, module not found. Why does it not find those modules? So remember we added them manually. In the monitor rest POM, we added them manually here. Why does it not find them anymore? So I'll give you a second while I update the IntelliJ to move to use Java 11. Okay, it's getting late where I am. So if you're from Europe too, you're probably getting tired. It's midnight here now. Because they're now external jars. Right, because they're not part of the JDK anymore. So we can't do this anymore. We don't add them anymore. And we have to add external dependencies. That's what I mentioned earlier. And this project is properly configured in the way that the parent POM defines in dependency management. This is the parent POM. And here in dependency management, it defines all the dependency versions. And then the individual subprojects only reference the names. But I'm too lazy to do that for this now. So I'm just going to add them with the versions. I copy-pasted this from the Stack Overflow post that I mentioned earlier. Right? These are just some versions that work. Not the recent versions, just some versions. Okay, if we do this now, then where were we with the POM? Here. Then we cannot add modules anymore. But then we can also no longer patch the module. So will that be a problem that we can no longer patch the module? And the answer is no. We had a split package between a JDK module and a dependency on the class path. Now the JDK module is gone, and we replaced both of them replaced it with the dependency on the class path. Now both dependencies are on the class path. They split packages between them. Not a problem for us, right? Remember, chaos of the class path lives on. So this goes away too. And now the entire configuration is useless. So if we want to keep this around, there we go. If we want to keep this around to keep working on Java 9, even though there is no good reason to do that, we would then have to limit this to Java 9.10 and be like, okay, this is just active on Java 9 and 10. And then this dependencies are just there for Java 11, but that makes no sense. We can just remove this. What about Java 8 though? That's the good thing, of course. These dependencies also work on Java 8. So once again, we're trying to keep all builds working, right? This build as it is right now, well, I put in var, so that change aside, this build will still work on Java 8, even with these dependencies. We don't have to use the JDK classes. And, you know, as I mentioned, it's important to try to keep the build as simple as possible and not try to add something in the profile here and something in the profile there. Many problems can be solved by updating dependencies or maybe replacing dependencies. And if you do that, you should always aim for a solution that works on all Java versions. Okie doke. That should work now. It does. Now Java version says we're on 11, so let's run this. Hey, we don't have to add the module anymore. Isn't that cool? It just got smaller, and this works. Great, and if you look at the endpoint, oops. Wait, what? The endpoint is empty. There's also a JSON endpoint. We can look at the JSON endpoint. Gern geschehen. And the JSON endpoint still works. Just the XML one doesn't. And this one took me some while. Like I came into this and was like, what's going on here? Like what? Why? And I'm not gonna, make you feel the pain that I felt. I'm just gonna show you the solution. Like this is the part where it takes the statistics and turns it into XML. And this is the part that does not work. Oh wait, we have to launch it from here though. Re-import, find the dependencies. We can then launch it from IntelliJ for the first time. Launch it from IntelliJ so the breakpoint works. There we are. It just, just seems to work fine. Okay, great. Now let's... Oh, sorry. Oh. No, we want to run it from here. And here we want to connect to it. And to the JSON endpoint, sorry, the XML endpoint. Okay, now this is standing still because we're in the breakpoint. And if you look at the exception here, it says no class def found error, Javax activation data source. And I was like, what? Why? And if you look at this closer, you will realize, and this is like, made me a bit mad. These dependencies here, they are third-party implementations of these Java EE APIs, right? But they themselves, so they're there so you don't need the Java EE code that's in Java SE, or that's shipped with the JDK. But they themselves use such code. The problem is that one of them, and I don't even remember which one, it was definitely, it was JAX-B, but I don't know which one of these artifacts. One of these JAX-B artifacts uses the Javax activation crap here, but it doesn't declare it as a dependency. So we had stuff that was part of Java EE that was within the JDK, and if we replace this with a third-party dependency, it will still depend on this instead of pulling, the third-party implementation in as a dependency. That, as I mentioned, took me a while to figure out. And those kind of stuff happened in the early days, right? It's now unlikely that you will run into these kinds of problems. Oh, the program is still running. So let's change that back. And now we can build here again. And we can then run it. And then we'll see that it starts working now. That was Java 11 update. The proper solution to this nowadays would be to always pick the recent versions. A couple of the updates that I made were not recent versions. A couple of things that I made here on stream was to show you those, and they're not the recent versions. Like many of these, I think actually all of these have newer versions now. And one of the newer versions down here declares this dependency. Let me quickly copy paste that. So updating, that's the name of the game. Update all your stuff. So just replace that. You will see that a couple of these versions are a bit higher now, and the data source stuff is gone because it's now pulled in properly. Okay, nice. We're done. Our application works on Java 11. And if we look at the diff, well, there's a var change here that I should probably revert. Where is it? Here. I just made it for demo purposes, right? We can still build this with Java 8 as well. This just works fine. So the changes that we made are mostly, there's a bit of code, works on all Java versions, or let's say both, 8 and 11. Well, we made a couple of comments. We added a bunch of not sure what that has to do here actually. Add a bunch of stuff, like dependencies. We added the dependencies. We added a couple of specific configurations for the Java versions, but not that many. We updated Maven plugins. We updated somewhere. We should find dependency updates as well. This is what you will commonly see. A few code changes. Most of the changes will be in the build system, where you configure the build, or particularly we update dependencies. This is where most of the work will be with updating to Java, to recent Java versions. And we're done. We did that. Now, if you're still up for it, we're going to spend some time and turn this into modules. Because it's getting late, we're not going to go very far, but I want to show you the first couple of steps. With what we discussed so far, remember when we did the first part, we discussed how to how the world would be if everything is a module. Now what we can do here is, because this is a small project, we can go into each of these and just create a module info Java file in source main Java. I'm back on Java 8, so IntelliJ did not yet realize that I'm back on Java 8, I think. What? That's weird. And in Java 8, it should actually not show me module info Java here. But what we can do is now we can go through all of these. How many are there? 1, 2, 3, 4, 5, 6, 7, 8. All of these 8 sub-projects. Add a module info Java to each of them. And then we're done. We can do this in an hour. That's great. If you can do that, go for it. Definitely the preferred solution. But what can we do if that doesn't work? What can we do if we don't have the manpower or person power? If there's not enough time, not enough resources to do it all at once. And this is where it gets interesting, right? That's the interesting part. And we're going to focus on that. What I'm going to describe now is not the recommended approach if you have the resources to do it all in one go. It will actually have a considerable overhead compared to doing it in one go, but it has the great advantage that you can now run on Java 11, that we already did that, and then you can start introducing one module after the other into your code base and start benefiting from that step by step, and maybe do the process over a year or something instead of over a couple of days, or maybe weeks if you have a large project. Let's turn to incremental modularization. A very important aspect and a source of a reason for a very long discussion I had with Oliver Drothbohm from Spring Data fame is that we disagreed a lot on what this term means. And I think mostly he's been right. This term is misleading in the sense that you might think all I have to do to have modular code is apply the module system. That's not true. And this term kind of like lends itself to that interpretation. My approach is, or my frame of mind was, you have a project, it's split into several jars, most likely if it's a bit larger. You probably did your best to make this a good split and have jars that make sense, that separate concerns. Now all you want to do is add the module system to it. You want to use the module system for reliable configuration, for safe encapsulation. You basically want to get something on top. That is what we're doing here. I'm not going to tell you, and neither does the book, by the way. It does not tell you how to create, how to take a big code base and decide where module boundaries should be. That's a different problem. I'm going to assume that you know how to do that, or that you already did that, and that you now want to use the module system to enforce those boundaries. Could someone recommend good online courses about Java? If you're not happy with the books that Manning has on offer and you want video courses, I think the ones on Pluralsight are generally speaking recommendable. I don't know all of them, but generally speaking, I think they're okay, at least. Some of them are really good. Some of them, but most of them are really good. So I can recommend having a look at Pluralsight. It's I think 30 or 40 bucks a month. Maybe you can get the first month for free even, and you can try it out. So you can just give a couple courses a little of a try and then see whether it's for you. Okay, so once again, you have jars already. We're just going to turn jars into modules. That's all I'm going to do. And why is that even an option? Because most module systems, you can't do that. Either everything is a module or nothing is a module. But we already covered that. There is this unnamed module thing which helps you with that. But there's something else which is called automatic modules. And we're now going to see how these two mechanisms, unnamed module and automatic modules, how they help you with incremental modularization. And this is based on a very specific thing that I did not really discuss. I kind of gave the impression that the class path is for jars and like plain jars, and the module path is for modular jars, jars with the module info class in there. And surely these are their main focuses. But the interesting bit is you can take a modular jar and put it onto the class path. Or you can take a plain jar and put it to the module path. So this 2x2 matrix with which path are you using and what kind of jar are you using is completely filled. All of these options are allowed and they do behave differently, and it's very important to understand that and how to use that. Okay, so let's start with the unnamed module, why the class path just works. I already showed you this. The unnamed module is what the module system creates for the entire class path content. The entire class path content gets stuffed into the unnamed module, has no name as I mentioned. We're going to see very soon now why that becomes critically important, that fact. It can read all modules, it can export all packages, and within it the chaos of the class path lives on. We covered that. Let's go back to the Advent project and let's fiddle with that a bit. That's also what we did with the monitor application that we just discussed. We did put all the jars, which meant our jars, in this case that's Advent and Calendar apparently, and all dependencies, in this case that's just Guava. The orange bubbles, you can see how artistically inclined I am, by the way. We put all these jars into the class path, and then the module system comes along, draws a big box around it and says, this is the unnamed module. And the unnamed module can implicitly read all the other modules. That's what these dotted lines are there for. They can implicitly read all the other modules, in this case all the JDK modules, and everything is fine. This works. This is what we just did. All our modules, all the jars that we built in the monitor application for Java 11, they now run in the unnamed module. The problem is, if you start modularizing your code, then you have to put your dependencies into these requires directives. You have to say your module requires your dependency. If your dependency is not yet a module and you put it onto the class path, then it's in the class path. It's in the unnamed module. But you cannot requires unnamed. And the reason for that is that you reference a module by its name. And the unnamed module's name is not unnamed. That's a sentence that should go into. It's a stellar example for good explanations. So the name of the unnamed module is not unnamed. It doesn't have a name. You cannot reference it. You cannot require it. This does not work. You cannot put Advent and Calendar into proper modules onto the module path and then reference your lousy dependency which is on the class path. That will not work. This is where automatic modules come in. They're a bridge from the modules, from proper low modules to the class path. You could also see them as a buffer zone maybe. So I mentioned that you can put plain jars, the old ones, right? The one with no module info class. You can put them onto the module path. And if you do that, then they get turned into an automatic module. That's important. Each of them does. All the jars on the class path end up in one unnamed module. Each jar, each plain jar on the module path gets turned into a single automatic module. And the interesting bit about an automatic module is we can start at the bottom. Just like the unnamed module, it does not properly define an API, so it just exports all packages. What else can it do? Just like the unnamed module, it doesn't define dependencies, so it can just read all modules. What else can you do? Interesting bit, very interesting bit. It also can read the unnamed module. That's important. That gives it that bridge capability. But its name, it does have a name. You can reference it, and its name is ideally defined by a manifest entry, or alternatively, it's derived by the jar name. So let's say you have guava 19.0.jar, and you put that into the module path. So guava, that jar does not have a manifest entry as far as I know. And if you put it into the module path, then the jar name will be used to infer its name. And so then Java will notice that this is a version and will drop it out and will give it give it the name guava. So for this guava jar, you get an automatic module name with the name guava. And then you can reference it this way. So it looks like this now. You put Advent into your calendar. By assumption, these are proper good modules. You put them into the module path, as you would expect. Somewhat surprisingly, maybe, you can also take the plain old guava jar and put that into the module path as well. And now the module system will draw a box around it and turn it into a module of the name guava. And then you can reference it. So the solid lines here are declared dependencies. Advent depends on calendar. Calendar apparently depends on XML, whatever. And calendar also depends on guava. These are defined as requires directives. Also within the JDK are tons of those. But guava is an automatic module, and it can implicitly read all the other ones. It reads everything that's on the module path and also reads everything that's within the JDK. So to put that into one matrix, you have two columns here, one for the class path and one for the module path. And what we discussed initially is the obvious choice. The regular jar goes on the class path and becomes the unnamed module. And the modular jar goes into the module path and becomes an explicit module, a module with the module descriptor and everything. The new thing we introduced here is this one. You can use a regular jar on the module path, and then it gets turned into an automatic module. And I didn't mention this, but you can also put a modular jar on the class path, and it ends up in the same unnamed module. Okay, so that means if you thought, well, the class path is for old jars and the module path is for modular jars, then that's not the right way to see this. What you should instead have as a mental model is not what goes on the path. That's not what defines the path. What defines the path is what it's for. The class path is for the unnamed module. Whatever you put on the class path ends up in the same unnamed module. The module path is for individual modules. Whatever you put on the module path ends up being a proper individual module. If it has a module descriptor and describes its properties, great. If it's a plain jar and doesn't describe its properties, the module system will create them for it. Okay? Class path for a single unnamed module, module path for individual, properly named modules that can be referenced. Okay. With these tools, we can have three modularization strategies. Bottom up is the most straightforward one. We're going to look at that with some code. And then after that, we're going to come back to the slides and look at top down, inside out as well. Let's start with bottom up. As I said, very straightforward. If you have a project, or if your bigger project has certain jars, certain subprojects that don't have any dependencies, or that don't have any dependencies that are not yet modules, then that's a good place to start. Or if you do bottom up, then that's the place to start. You can take these jars and then turn them into modules, right? Because by assumption, all the dependencies are either there are none, or the dependencies are already modules, so you can properly require them. You can put them into the module path. Everything will work. You can work bottom up, and you can turn your jar into a module. And now the cool thing is, they still keep working on the class path, right? If you take a module and put it into the class path, it ends up in the unnamed module. It behaves exactly as a plain jar on the class path. That's good, because that means if you decide to create a module, then that does not force your users to use it as a module. That's really powerful. You can create a module and users can be like, I don't care. Put it onto the class path, do whatever. And then they can decide when and where to put it. And well, once you have that, then you just go upwards from there. So we're going to do that for a single module. How do we find that though? How do we find the bottom of the dependency chain? Well, there are several ways to do this. One straightforward way is to use your dependency tool, and you can say, let's call Maven Validate. Maven Validate just checks a couple things, but the cool thing is it's a very, very quick way to get the reactor summary. This is the build order. And the reason this is the build order is because it starts with the projects that have no dependencies and then starts adding dependencies. Right? Oh, not starts adding, sorry, starts building those that depend on the one that came before. But you may have a lot of external dependencies, and it would be nice to see them as well. And this is where JDEPs can come in again and can help. JDEPs, as I mentioned before, is really cool. So let's use JDEPs, and let's ask it to create a summary, because otherwise it will spill out dependencies on the package level by default, which is, I don't know, not helpful in this instance. Want to go recursive because, oh wait, we have to make sure that we actually build the thing first. Validate is very short. At the very first steps, it just checks a couple of things. Verify is basically the last thing before install. So almost the same word, quite different meaning. Okay, I'm not gonna type it out. Let's just copy paste the JDEPs command. I can talk you through it. JDEPs, please create a summary. Recursively go through all my dependencies. You will find them here. Start with the main jar. And I'm not going to explain this. Let's just leave it as it is. If we do that, we get this. This tells us that Jackson Core jar uses Java Base, for example, and JaxB RP jar uses Java Base, and Jetty Util jar uses Java naming, and this is where we come in. Main jar uses all kinds of stuff. Okay, that's neat. What else can we do with this? So the first thing we can do, we can decide, you know what? We just care about our own stuff. We don't care about all the other. We just want to see a dependency graph which involves our modules, or sorry, our sub-projects. We don't care about the other ones. JDEPs once again can do that. We can have this include here, which says just include all the packages. Sorry, remember it works on all the classes. It analyzes based on classes and then aggregates by default to packages. In this case, aggregated further to artifacts. So that means it works on fully qualified class names. And if we do it like this, we say everything that's monitor, whatever, just operate on that. That's a bit shorter now. Okay, that's nice. We get this now. Now comes something that's really handy. You can automatically create diagrams with this. So there's an option that's called .output. .output. And because we create a summary, it will just be a single file, and we create the single file in this folder here. Now we don't see anything, but we now get a summary dot. This is new. This wasn't there before. Okay, this here created the summary dot file. And if we look at it, then it has this syntax. That's a common way to put a graph into text form. And there are several tools that can build, that can create graphics out of this. I use GraphViz, which has the dot tool. So let's tell it to create a PNG. As you see, I'm watching over the side here because I don't know this by heart. Let's create a summary dot. Oh, sorry, let's create summary. Let's take it input summary dot. Okay. And now we created the PNG file. And we can take a look at that. Let's use GwenView for that, summary.png. And there it is. Look, there's our main jar, depends on persistence, uses utils, uses Java base, REST uses Jackson core, and these, see how these have no outgoing lines? Because we didn't go further. We limited all our dependencies to our own packages. So while it realized that REST depends on Jackson data bind, it did not go into it any further. We can clean this up a bit. We can remove Java base because, you know, that's just noise. Everybody depends on Java base all the time. And we can remove the .jar as well. And the good thing about that is, because we're operating on a class file, sorry, on a text file, we can use a couple of very simple tools to edit them. And so on Linux you would use set. I'm sure something similar exists for Windows. What this means is replace, so in this file, in place, apply this replacement. Let's not dwell over the details. This removed Java base lines. This removed all the lines that contain Java base. This removes all the .jar endings, and then we can repeat dot. And I'm going to tell you in a second why would I explain this in such detail? Because I want to show you how powerful this is, because now we get this graph, which is much better, cleaned up, very easy to read. And remember, everything I did here is a simple script that you can run at the end of your build. And I find the idea that at the end of each build, you can get a proper representation of your actual architecture, as opposed to somebody's diagram that was, you know, photographed from a whiteboard 2 years ago and put into Jira and never updated. This is your actual architecture. You can build this with each, you can create this with each build, put it on a screen somewhere, and then you can walk by and you can see how it changes over time. I think this is really powerful. And let's keep it around so we can look at it every now and then, because this tells us where to start. This tells us that one way to start, for example, would be utils, because it doesn't have any further dependencies. And if you want to start bottom up, you look for these bottom things that don't have any dependencies. Let's start with utils. So let's go there, utils, source, externally edit, files came into get, no. Java, new module info Java. We do this here in utils. It's called monitor.utils. Remember, you should have better names. We're going to be fine with this. Remember, we don't have to require Java base. It does that by default. So there's that. And no other dependencies. But we do have an API, right? We have the utils class here, which apparently lives in the monitor utils package. So it kind of makes sense to assume that we want to export that. So let's do that. Let's export, oh sorry, that's not common actually. Exports monitor.utils. Okay, that's that. And if we now go to the command line, and build this, we won't see a difference. This will just build a thing. Maven does this for us. Maven realized, hey, wait a moment, there's a module info Java file. Where's the cursor? Here. There's a module info Java file. So we want to build a module apparently, and then it just does the right thing. It puts the dependencies in the right places. Well, we didn't have any, but if we would have, it puts those in the right places. It all does the right things. And we can test that because we can ask the jar tool to help us identify what's going on. So we can use the jar tool, and it has a new mode that's called describe module. Very important if you want to figure out stuff about modules, about jars, what state they're in, whether they're modules or not. So describe module, and you'd use that you tell which file to use. We put that into app, and that's called, what's called utils, right? Monitor, it's just called utils, utils.jar. So we can, for comparison, we can also use main.jar. So if we ask it, use main, or sorry, if we ask it, utils.jar, please describe this as a module. It will say, okay, so monitor utils.jar, that's its version, it inferred it from the file name. Oh, sorry, no, Maven put that information in there during compilation. This is the path. There is a module info class in there, that's what this means. It exports that package. and it requires Java base because it's mandated. Everybody has to require Java base. Okay, cool. So that's how it describes that module. It's a proper module. If you ask it to describe any other jar that is not a proper module as a module, it behaves, as if you would put it into module path. It assumes it's a module, or it wants to be a module. So it says, look, I didn't find a module descriptor, so I derived the automatic module. I derived the name main, because, main without .jar. It requires Java base because everybody does, and it contains the package monitor. And later at runtime, this will mean it will be exported. The package monitor will be exported. So we just create a module here, and yet we can still run this from the class path. Application works like before, everything's fine. So that means we just create the first module, but we don't have to use it as a module. What do you gain by that? Well, one thing I gain from that is that I still compile it on the module path, and that means that I still get strong encapsulation of this module towards its dependencies. If I would use a dependencies internal API, if that dependency is a proper module, I would get an error here. Not here, but during the build earlier, right? So if this monitor utils would say requires foobar, and foobar is a proper module, then I cannot use foobar's internals. So that's something I gained here. But now let's use it as a module at runtime. This gets a little bit trickier now. First of all, we have to remove that folder. Okay, there it is. This gets a bit trickier now because it's easier, or it's shorter rather. It's shorter to operate with class path and module path. We can mix that, and we're going to do that now. If they're in different folders, they don't have to be, not at all. You can have things in the same folder, and then you add each individual jar to the class path or the module path. But that is really painful on the command line, so I don't want to do this. So instead, what we're going to do is we're going to have one file. We're going to call that move modules.sh. So it's a short shell script, and I'm going to copy paste this. Where is it? There it is. If you're not familiar with Linux, ignore the first two lines. This means remove the folder mods, it's already gone here, and then recreate it. This creates a new empty folder every time we run this. So the idea is we run the build and then we run the script once, so it puts the modules into the right places. And we just created our first module, namely we created app.utils.jar, and we want to move that to mods. Yeah. Okay, so this is, let's do this once, just so we see how that oh yeah, we have to make it executable first. So every time we build, we have to run move modules afterwards, so we put them into the right place. We could ask Maven to do that, but when configuring Maven takes a lot of time as well, so I think this is the quickest way. So utils is gone from this folder, it's now this folder. And now we can try to run this. So let's create a run script, and because I'm lazy, I'm going to copy paste this. Let's run this. How do we run this? Before we used this command, and this command worked, but now everything's on the class path, and we don't want that anymore. So what you would think, what would be the easiest thing, is to just say, look, we're just going to put something on the module path. We're just going to say the mods folder is on the module path now. Okay, so we're going to say here, start the monitor.main class. If you're looking for classes, you will find the modules here, and you will find the class path here. So in this case, it's a bit easier if I use IntelliJ's. If I use IntelliJ's terminal for that. So let's run this. Doesn't work. It launched, all right? So main prints this, so that worked. But as soon as it tried to get to utils, it threw a no class def found error. What can we do? How can we figure out what's going on there? There's a pretty cool command line flag that can help us here, and that's called show module resolution. While we experiment with that, No, let's stay here. Let's just increase the size of this thing. Let's run again. And what it prints then is, well, what it does. What it does related to module resolution. The module resolution, that's the step where the module system tries to figure out, okay, you told me something about modules. Let's figure out what I'm doing here. Let's say you told me to start with that module. I'm finding that module. I'm looking for its dependencies. I'm loading those. That's what it's doing. That's what show module resolution does. It shows you that. But we're in an interesting spot here because we're running an application from the class path. And that means that the module system realized, wait a moment, I don't know which module to start with. So what I will do instead is I will pull in all the Java modules first. So this is all the Java stuff. That's why all the Java stuff is available. It says, okay, I will start with all the Java stuff. And then the Java stuff does all kinds of things, right? This module apparently depends on this module. And then JDK unsupported, desktop requires Java desktop. And then, oh my God, requires. Tons of stuff, requirements. Java desktop requires Java preferences. Java naming requires Java security. Java base binds slow stuff. That's related to services. We didn't look into that. More. None. Our module is not mentioned. Our utils module is mentioned nowhere. We can check by grabbing for the term mods. Utils. It doesn't appear. Utils is not mentioned. The reason for that is what I said earlier. Stuff from the class path is just available. But stuff from the module path is only available if in the beginning it is referenced. When in the beginning the module system realizes that this is needed. And if it's needed, it pulls it into the module graph. And if it's not needed, it does not pull it into the module graph and it's just not available at runtime. Because nobody yet uses this module, we have to pull it in manually. Basically, you have to do something like this, where the JVM decided, look, nobody tells me to, but I'm going to assume that we're going to need all of these Java modules, right? Like Java logging and stuff. So if you migrate bottom up, you will, and if you want to not only build modules, but also use them as modules, on each launch, you will have to explicitly reference them, which is a bit of a pain. We can do that. We already know how to do that with add modules. And now we use the module name, which is monitor.util or utils. Which one was it? Oh boy, this is really small now. It's utils, plural. Okay, monitor.utils. And if we do that, then we'll see the same output here, but somewhere monitor.utils should be mentioned. There it is. We added it to the set of root modules. So now it's in there. And now the application works. So what we did is we put all our stuff, most of our stuff on the class path, but then we also added a single module on the module path, and then with add modules, we put it into the application and now it works. Okay? And what we can do now is we can start applying this elsewhere. We can start doing the same. If we look back at our tool here, we can start doing the same with Observer. So let's do several at once. Let's do Observer and Observer Beta and Observer Alpha. Let's do all three of these at once. Okay? So, new module info Java, that's going to be monitor.observer. And then this is the package that it exports. Exports monitor observer. And then we look at alpha and beta. I'm just going to copy paste this. Alpha, there it is. Yes. So now I get an error because we already know that, well, that's an error because now this module now says it exports a package that is not even in here, and that's not legal. The compiler would not let that stand. You can only export packages that are actually there. And then this would lead to problems as well because the name is already taken. This would lead to problems later. Okay, we can try this, but this will not work. And the reason this will not work is when building this, Maven knows about its dependencies, right? Maven knows about the dependencies. It knows that monitor observer alpha, whatever that does, uses observer. This depends on this. Maven knows that. It places this jar, or rather that folder, it places that on the module path for this one. On the class path even. It places on the class path, but even if it would place on the module path, it wouldn't work either way because it is not declared here. So what we'll see now is a compile error that a class was not there, right? So we get a compile error that it cannot find these symbols. It cannot find, so in monitor observer alpha, this dependency is not visible. And the reason is that we don't declare that we require that require that dependency. We should say requires monitor observer. That's alpha, and let's do the same for beta. Yes. Beta. This is beta. Okay. Nice, made that work. We built the thing, and let's try. I've earlier had this problem that the compilation was weird and sometimes doesn't work, but I want to show you something. I hope it works now. We go into monitor observer alpha and quickly clean, so we force a recompilation, and then we compile with a -x to get more input. Not sure why it doesn't find this module, but doesn't matter, because I want to go back and see the command line options here. Because here, this is the full command line options, right? And it starts with which directory to put the source, the target, so to put the class files in. And then it mentions the class path here. Oh, observer jar. Oh, okay, maybe I have to install after all. Because what I was hoping for is that you would see that some of its dependencies on the module path and others on the class path. That's what I want to show you. Let's see whether we can make that visible. There it is. Now it works. And now it goes through as well. So here you see, that's what I was showing you. Source roots, let's ignore the source roots. This is the important part. It found out that it had used the class path for parts, and for other parts, it uses the module path. Okay, so Maven detects that, oh, you're building a module, or you have a dependency on something. So that dependency needs to go into the module path. Everything else that is not a direct dependency, well, doing compilation doesn't make a lot of sense, but everything else can go into the class path. So Maven does the right thing for us here. Now we have to do the same thing for our launch script. Let's first add these moves. Move, yeah, move. Observer, and I think observer alpha and beta. Oh yeah. Okay, they're in the right place now, I hope. Yes, there we are. Good. Now we can work on our run script again. So which modules do we have to add? So one way we can do this, we can just add all of them. This will surely work, but also it's a bit unnecessary. Like if we do it like this, and then we run, it works. And we can see up here then, there we are. We get, do we get more? There are the roots. Root monitor observer beta is this one. Root monitor observer is this one. Root means this is where the module system starts looking, or where it starts, and from there it finds dependencies. All four are here, and that's great. But the cool thing is, and ideally that's where you want to go, if you do these kind of migrations, you don't want to just go like literally bottom up, like all the lower rung, and then one step up and then one step up. That's kind of a pain. It's better to start in a corner and then go upwards from there. Because if you add a dependency on observer beta, sorry, if you add observer beta as a, on the very left, right? On the very left, you can see it, right? There's observer beta module. It depends on observer. You don't have to explicitly add observer yourself. You don't have to do that. We just are in kind of a weird spot where we have to add a lot of modules ourselves, but generally speaking, you don't have to do this. Generally speaking, you can just add the top of these trees, and then the module system will add the other ones on its own. In this case, that means we can just add observer beta and alpha and utils, and then observer will get pulled in on its own. Right, so if we do that, we move observer here and then run it again, we will see that in the roots, observer is now missing. There's observer alpha, there's observer beta, and there's utils. But observer itself is missing in the set of roots. It will appear later when it's needed for the first time. There it is. Monitor observer beta requires monitor observer, and there it is pulled in. Okay? So when the module system started in monitor observer beta because we added it up here, but then when it looks for its dependencies, it looks onto the module path and it finds monitor observer here. Okay, so that's good. Let's see how much further we can get. Is there something more interesting to show? We can do REST, but I have to admit, I'm a bit afraid of REST for a very specific reason. I don't even know whether I have a solution for that. Let's do main first. Let's do statistics, persistence, and main. Because if we do that, then we basically can start with main. It's a full screen mode as well. I didn't know that. My goal is we do statistics, persistence, and main, and then we start with main. Then we have all of the left-hand side of this is modularized, utils as well, but we leave REST on the class path. Then we basically go into top-down territory. You know what? Let's start with main. We did a bit of bottom-up. Now let's do top-down as well. I would not recommend to mix this way, but you can. You can look for pockets where it makes sense, and if you run into a hard barrier that you cannot fix on the short term, you can start somewhere else. But as you see, like maintaining these kind of launch scripts is not trivial. And you may run into situations where you have to do some of these things for your tests as well. Because at the moment, the tests for monitor observer, the tests for main, for example, because main is not a module, monitor observer beta will be on the class path. So even though it is built as a module, it will not be executed during tests as a module, which should be fine, but you would prefer to test it in a way that reflects how it's going to be used. And that means if you want to use observer beta as a module, while you're in this bottom-up approach, you not only have to add it here, you also have to add it to your test scripts, which is a bit annoying. Okay, let's go with main though. Let's go with main. There's main. Source, main, target, Java, new module info Java. This is just monitor, and it requires all the other ones. And now we can do, now some things are interesting, right? The mods, this is the name of their jars, but they do have proper module names, and the proper module names all start with monitor. So that's monitor observer. Does it need observer itself? Yeah, there's an error here, so it needs all of them. As I mentioned earlier, that's not something you would hope for in a properly split project, that one of them depends on all the other ones. That would be kind of sad, actually. So this is beta, observer, and observer alpha, and then utils. Monitor. Oh, IntelliJ, thank you. But we also require these persistence, statistics, and rest. And they are not modules, right? They are plain jars. They are in here, and their names will be different because the rest, let's pick persistence. Persistence does not define a module name. So it will pick the name of the jar file. Okay, so it requires persistence. IntelliJ complaining straight away, which is a bit annoying. I thought you could figure this out. And then rest, and then statistics. Main uses beta, observer, and alpha, and utils. We had those, and rest and persistence and statistics. Those are automatic modules, because once again, we can just keep one of them out of here just for demo purposes. It will not compile them because it will not find these classes. And the main class doesn't have any API. It doesn't export anything. So we can just go ahead and build this. Oh, look at that. What was that? Here. Required file name based auto modules detected, blah, 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 blah. Please don't publish this project to a publish artifact repository. I'll get to that in a second, what the problem is here. But the compilation, and we forced it on purpose, right? It says the package monitor rest is not visible because it is declared in the unnamed module, but module monitor rest does not read it. We basically, on purpose, forced a situation like this, where one of our dependencies is on the class path now, and that doesn't work. So what we have to do instead is we have to declare that as an automatic module. We already did this, so we now this works. Build works. Now, when it comes to moving our dependents, our jars, our modules, sorry, yeah, we can move main as well now. And now let's go to run sh. So we switched modes now. We were in the bottom-up approach, and the bottom-up approach, what you do is you add basically, assuming you have a deep tree, you start at the bottom and you add the tip of each tree to these add modules. In that sense, this tree, what starts in observer, now ends in main. The one that starts in utils ends in main. Alpha and beta observer also, they're all related from main. So we don't need any of them on the module path. We can just use main here, and we can even go one step further. We can say, wait, we don't have to add this. We can properly start on monitor main, right? We can say monitor, that's the name of the module, / monitor main, that's the name of the class. Let's start here, because its dependencies are modules, and we'll find the declared dependencies on the module path. Or so I have you believe, but it won't work. What? Not what I expected. Oh yeah, right. To launch a module, you have to say module. Otherwise, it expects to load a class. What? Why? Oh, I did not move modules, did I? I did not. There, yeah, that's a problem. I need to move the modules. There it is. Okay, Good. That's the error I was expecting. So error occurred during initialization of boot layer. Java lang module find exception module rest not found required by monitor. So what's going on here? If we look at the graph, we'll see that monitor, that's main up here, it requires rest. Okay, is that so? Let's check. Yeah, it requires rest. Okay, where is rest? Where's the jar for this? Well, the jar is here in the app folder. And we put the app folder onto the class path. Here. And remember, we cannot read the class path from a module. So the problem is now that we basically have some dependencies. We don't have the bridge yet. We have proper modules on the module path. We have everything else on the class path, but the bridge, the automatic modules, may even build it for us during compilation, but we have to recreate that now to run. And the way to do this, there are several ones. One I want to do here, not because it's ideal, but because it's maybe shortest and easiest to understand, is right, we need to remove the other ones to the mods folder. They are not really, like they are not full modules in that sense, but we can treat them as such. So maybe we can say move explicit modules, meaning modules that have an explicit name, and then we can say move automatic modules. So I saw that earlier that Kandre won a book, right? I think he or she well deserved it. Really paying attention. I appreciate that a whole lot. It's 3 hours in and you're still present. That's great. What? Move app dot rest, right? Rest was the problem, and persistence and statistics will be the same problems. Look, this is how lazy I am. Jar, and we move them to mods. Now we can put in the right names. That was rest, statistics, and persistence. And this is interesting now, because now, wait, can we open this? Let me quickly, yeah, I think that works, right? I think I can open GIMP as well from the command line. Sorry, .png, let's send the background. Okay, that's good, because we have a couple modules now. So let's pick a color from modules. Let's pick a nice shade of green, because of course green is good, right? So now this is the module path. Oh my god, this is horrible. We cannot read it any longer, but that doesn't matter. Let's ignore the names then. This is a module on the module path. This is a module on the module path. This is, and this is, and then this is as well. These are modules on the module path. Okay? Look what we're going to do. Highly professional. Yeah, great. Oh, actually, no, we can actually type text. I don't have to write it out that way. This is the module path. Oh, sorry. This is explicit modules, which is mod jars on NP module path. And now we're gonna pick another color. Let's pick a nice bright pink. There it is. And all of this will be class path. Oh. All of this will be class path. Right? Those will be left on the class path and their dependencies as well, because we don't care about those. The problem is there can never be a connection from a green to a pink dot. The green dots cannot see the pink dots. We have to have something as of a bridge in between. And this is where we've been using automatic modules, which are this one, and this one. These are now automatic modules, which means automods, which is plain jars on the module path. Like, okay, we're running out of space here, but you get what I'm saying, right? So that's important. If you color all the explicit modules one color and all the jars on the class path in another color, then they can never, like, the green, like the class path, the module path can never reference, or the explicit modules can never reference the other ones. You need these other as a buffer. And the most obvious is here for REST. Here you can really see this. Main requires REST, and that dependency is mentioned. But what REST needs, that dependency is not mentioned, because REST is ugly stuff on the class path. Talking about ugly stuff, GIMP, shut up, don't. Oh, look at that. GIMP pickable continuous region by seed. Huh, that's interesting. Took 0.2 milliseconds. Nice. Good to know. We move them there. And then when we run, they will be found here, and their dependencies of all explicit modules are here, and dependencies of the automatic modules are here. Okay, that should work. I do the copying manually because the script will otherwise fail on the first not found dependency. Move, yes. Hey, it works. Look at that. And now the cool thing is that the root modules got really small. Now only monitor is a root module. That's really, really cool. When you start top down, then you will only have a single module as root, and maybe a few if you add modules, but most likely you don't have to. So there's a single root module here. And now the module graph is a bit smaller because fewer things from the JDK will be in there. But you see that monitor first requires persistence. It finds it here, looks at automatic jar, automatic module. It finds monitor observer alpha. It finds all of them. And then it requires Java base because everybody does. Java base is always in the game. And then Java base service binds a whole lot. And then the ones that it binds in, they need different stuff, blah, blah, blah. But here it works. And that's really cool now. So we have a very mixed approach here. And I would not generally recommend to mix them that much. But you can if you feel like that's the best way to go for you. Yeah, okay. No, the problem with REST is, remember the split package thing? Remember that? That wasn't good. That wasn't nice. So there is a package split between JSR 305 and something else. Wait a moment. Why does the other part of the split not appear here? Oh, I know why. Okay, here's the thing. These JDEPs works on bytecode. And as I mentioned earlier, some of the annotations are not present in the bytecode. That's why they do not appear in this diagram. But yet they're there. REST had all of these dependencies, right? REST had these dependencies here. Monitor REST, POM, that one and that one. These two, they split a package. And the problem is, now we need both of these as modules, right? If REST becomes a module, we require both of them as modules. Automatic modules, but still as modules. Now we have a package split between two modules. And the module system will say, not gonna do that. Now you can say, ha, I know how to solve this. Patch module. And you're right. You can patch the classes from one of the modules into the other module. But you know who doesn't know that? Maven. Maven will still place both of them on the module path. And of course, patch module does not literally empty one of the jars. What you will do is, you will have, instead of two jars with a bit of an overlap, you will add all of these classes here. So you will have one class, one jar, that, or one module rather, that contains the other one plus extra. You will still have a split package. You would have to tell Maven to, yes, it's a dependency, but it's not a compile dependency. You would have to switch it to provided, And oh my God, let's not go there. Can show difference on memory footprint. No, I don't think I can, because I don't know how exactly I would do that in Linux. But also, I don't expect a big difference. I mean, surely the module system will not be smaller, because Java is already lazy. That we pulled in fewer modules does not mean that we load fewer classes, right? We always only load the classes we actually need. That's just how Java works. So we did not load fewer classes. And I would guess that Java 8 is pretty fast in general. The module system adds a bit of overhead. So I would not expect a performance improvement with just this approach alone. What you can do based on this, you can start using JLink to create a runtime for your application that just contains the stuff that you need. And that can be kind of handy, because then you have less memory, but not less runtime, and not less RAM, just less disk space. And that is not important in many cases. Okay, I think we're coming to a close here. Let's quickly go through the other approaches. I went a little bit through bottom-up. I covered bottom-up extensively. Let's look quickly into top-down. If you have a project that has unmodularized dependencies, like an application, you can start modularizing at the top if you want. And I think that's an okay approach too. You don't have to start at the bottom, because even your bottom jars will most likely still have external dependencies. So they're basically more like in the middle. They're at the bottom of your dependency tree. But if you look, or like of the jars you have control over, but if you look over the entire dependency tree, right, this shows it all. Like when I look at my stuff, REST is at the bottom. But if I look at the full tree of my application, REST is in the middle. Even actually closer to the top. If I look at all the other dependencies as well, REST will look very far to the top. So I think it will mostly be top down. As before, you can start turning your jars into modules. And now it gets a little bit more tricky where to put dependencies. The dependence, if you start creating modules, then your direct dependencies, you have to require them every time, right? You have to require all your direct dependencies. And I would recommend to put all your dependencies that are modularized on the module path, or at least the ones that you require directly. This is what Maven does the latter. Maven starts with your module, places all your direct dependencies on the module path, and then goes on placing all direct dependencies of another module onto the module path. So if you build main, then Maven does the following. Okay, Maven depends. Let's assume it would only depend on the first. Oh, you cannot see this, I think. On the first row here. On the first row, observer beta, persistence, observer alpha, and rest. It would put these 4 onto the module path because main needs them. But then for rest, it would realize, oh, REST is not a module itself, so its dependencies, they can go into the class path. And I think that's a very sane approach. It works really well. And you can mimic them, basically. That's what this slide describes, to mimic that approach. And that means then you can get into a working state. And now when a dependency gets modularized, we hope that the name didn't change. And if it's already in the module path, nothing changes. What I mean by that is, let's say we're in this case again, and now somebody modularizes REST. Well, this would be us, right? But let's say somebody modularizes REST. Then ideally for main, nothing changes because main already required REST and is already on the module path. So that's good. The name will change, so that's a bit unfortunate. But if it's your code and the name changes, it's really easy to fix. You just put a monitor in front here, right? I'll come to those questions in a second, both of them. Let's quickly finish this. If they're not on the module path, you have to move them there. And then you will check their dependencies, and because their dependencies have to be on the module path as well. But as I said, your build tool will do this for you. Now, we also have inside out. Inside out means you're in the middle of a big dependency tree. That's basically where REST is, for example. And this basically works like top-down, really. What this means is you modularize yours first, you put your dependencies onto the module path, there might be automatic modules or not, all of that is The same, but there's important detail. The important detail deals with automatic module names. If you depend on an automatic module, then this name can either be from a manifest entry, which is good because that is well defined, it travels with the jar, it stays intact, that's stable. Or if it doesn't have a manifest entry, it depends on the file name. And that's dangerous because that file, that jar might, not that file, but that jar might very well get a different name on a different machine, on a different operating system, on a different build tool, wherever. So if that name of the file would change, then the name of the automatic module would change. And then you have a dependency on something that that somebody who depends on you, right? They depend on you, you depend on something else. What you depend on might have a different name on their machine, and then your dependency is not found. And that breaks, right? So if the file name differs across environments, and also when the module name changes, when something gets modularized, in that sense, these names are unstable. And that's a problem because then if the names are unstable, they can change over time, or even worse, two projects might depend on the same dependency by different names. Then you get like the diamond of death stuff. That's not good because then this project depends on both of these. They depend on the same thing by two different names, and there's no way to fulfill this requirement without massive contortions. So do not publish modules that depend on automatic modules whose name are based on file names. And we've seen that from Maven. Maven was complaining about that earlier. That was the message that I showed you. Let me see what I can find. I can't apparently. Remember Maven said like, do not publish these to the repository because you're using blah, blah, blah. Well, that error message, that was the reason for that. There it is. Required file name based auto models detected, blah, blah, blah. Please don't publish this project to a public artifact repository. Okay, that's the reason why. So that means if you have your own application, depend on automatic modules by file name, go at it. Not a problem. You just have to update them maybe at some point or frequently. That's a bit annoying, but that's not a problem. But if you're in the middle of a dependency tree because you're publishing a library and people depend on you, you cannot do that. You have to wait for them to add a manifest entry before you can publish your own module. It's a bit unfortunate, but there's nothing you can do about that. So while it's okay, and that's okay then, right? If they define a module name in their manifest entry, then that's okay. And that's that. Thank you very much. Wow. Although actually it's not that wow. I often stream for 3-4 hours. But usually it's more coding and thinking and less talking. But as you might have guessed, I'm okay with talking a lot. Okay, so let's go through a question. Do you see anything like tree shaking? You know what? I always want to know what tree shaking was. Why not find that out now? In computing, tree shaking is a dead code elimination technique that is applied when optimizing code written in ECMAScript dialects like the... Okay, when it comes to modules as the atomic unit, then the module system does tree shaking in the sense that if your module path contains 100 modules, but you only need 2, then the final module graph will only contain these 2 modules and none of the other ones. They will not be accessible at all at runtime. You cannot add any command line flags, nothing. As I mentioned earlier, the module path and the module graph, including the unnamed module and its content, all of that is created during launch and then it's immutable throughout the rest of the execution. The only thing you can do is you can create an entire new, this combination of module graph and a class loader with an unnamed module attached to it. This combination is called a layer, and you can create several layers, but you cannot mutate a single layer. So in that sense, you have tree shaking, I guess. Counter writes, I have a massive migration project from Java 8 to 11 coming up and was anxious about it, but not anymore. Thanks to your awesome presentation. Oh, thank you very much. Yeah, thank you. That's very kind of you. Hit me up on Twitter. I'm NipaFX there. If you have any problems, go to Stack Overflow. If they're not fixed there, maybe ask us questions Stack Overflow and let me know about it. Maybe I'll find the time to answer. I always want people to upgrade, and I'm really happy if this helps. As I mentioned a ton of times, this can be boiled down to 3 seconds. Upgrade all the things. Do that first, then try the rest. Alfred, just preparing for 1Z0816. Okay, Java Oracle certification, Java Programmer Part 2, and your stream was very helpful. Thank you. Sure, thank you very much. I never tried that. I'm not a certified Java programmer. I'm a Java champion, but I assure you I will not pass those tests because I've seen some of these questions, like crazy, like operator preference, not preference, what's it called? Operator, not preference. See, I don't even know the term, damn it. The order in which they evaluate it. And then like this, I don't even know what the single, like what this is. I always forget what this is. Like you can write an or like this, right? Like I forget, is it bitwise or something? Like look, these questions are crazy. I would not pass. Precedence. Yes, operator precedence, you're right. What do I think about Kotlin? I like, by the way, I don't consider that a personal question. I like Kotlin. I think, unfortunately, I never got around to actually working with it. In practice, in prod. I had on hobby projects, but I never put anything in production with it. There are a couple of things that I like about it, and most specifically, that's how it's handles null. I heard from a couple of people that while how Kotlin handles null is amazing, if you have to interact with Java libraries a lot, it all falls apart and becomes useless. Can't speak to that. But I have a really strong opinion on null, and it's not a very positive one. And the way that Kotlin handles that, it's not unique to Kotlin. Other languages did it before that, right? But Kotlin does it really well. And I think in general it's a pretty cool language. And what little I experimented with it, I enjoyed it a lot. Yeah. Okay, what else can I like? Because Manning told me I can plug my own stuff, which I guess I did with with that thing over there. But other than that, I didn't do a whole lot of plugging, right? I mentioned the book, Twitter. I Twitch stream once or twice a week. You know what? Let's go there. Yeah, that's my Twitch stream for the month. So we finished May 1st, check. And we did a lot of JNet Pioneer, which is a JNet 5 extension project. We'll deal with that a lot. And do a bit of gaming every now and then. Oh yeah, in May 23rd, Java turns 25. I do a 25-hour stream. But I won't be the only one talking. Don't worry. I'll have guests there. Brian Getz, Venkat Subrahimian, I butchered his name, I'm sorry. Trisha G, Kevin Henny, Martin Verburg. I think that's all. I hope I didn't forget any one of these great. So great guests, great topics, plenty of fun. You're crying tears of blood because you have to work on Java right now? Ah, come on. You'll move to Java 11 and then afterwards it gets better. It's not like 8 is bad. Look, the thing is, like I worked a little bit of TypeScript and very little Kotlin, and that's all I know. So it's really easy for me to like Java. Like I don't. that sounded bad. That didn't come out right. I like Java and I like how it's moving. Yeah. What else? Oh yeah, I run a conference. Do you recommend to work with Java 14 and module system? So when you start a new project, my recommendation is start a new project on 11 or 14. That's a question of licensing. So that's a little bit more complicated. But I would always start with modules, because the cool thing about modules is if they don't work, you can back out really easy. All you have to do is delete all your module info Java files and you're out. And if you use them while you go, I think they're way less effort than if you introduce them at once into an existing project that was not built with them in mind. I highly encourage everybody who starts a new project on Java 9 or later to start with modules. And as soon as you feel like, wow, this is getting painful, I don't think there are a lot of cases where this happens. But if it would happen, you can back out easily. And if you consider how much time you spend on writing code and tests and hopefully documentation and discussing things with project owners and all that kind of stuff, maintaining a 10-line file should be comparatively easy. And if you want to know, I wrote something on Medium. What is it called? Medium, and I think take care module declarations Java 79 things. Let's see whether we can find it. Yes, there it is. There's another advantage. Let's quickly scroll O'Reilly out of the picture, or I get into trouble from Manning. I don't know whether I do. It was just a joke. Read that. There's another advantage to multi-declarations, and they're a great place where all of the information about a single jar come together. And if you just, ideally, if you have a properly structured application, then just looking at these multi-declarations should give you a good impression of what this is about. You can see what the packages are called that they export. You can see all the dependencies in one place. It's a really good way to get a grip on a project, or so I assume. I never came into a project where other people wrote modules and I could start understanding them. So, who knows? Something. Never mind. Accento. I run a conference. Accento. It's in the description text. I don't want to drag this out any longer. What I do want to do though is I want to rate somebody else. That's going to be fun. So I'm gonna select a stream that we can rate now. Oh wait, I cannot rate. Damn it, I can't. Because this is Manning's account and I can't rate somebody from Manning's account. State of the module system from the spec. Yeah, I'm not sure whether that's still up to date though. Last updated, no, the file that you linked was updated a year and a half before Java 9 was released. I would not, I mean, it's great to read that. It's great history. I would recommend working through that. I recommend working through that, but I would definitely not base an exam on that. I didn't update the upcoming thing I see right now. Never mind, I don't want to drag this out longer. Thank you very much for being here. I had a ton of fun. I hope to see you around on my Twitch, NipaFX, on Twitter, at a conference near you. Ping me when you have any problems. You can ping me on Twitter. My DMs are always open. I always glad that if I can help, and I hope that I appreciate that you are. I hope that you can start moving to Java 11 now, because I really want everybody to be there. Have a great time. I'll see you around.